This time in Art and Code, we're back coding in the kitchen again, exploring Catmull curves and doing some generative drawing. This time on Art and Code, I'm back in a coding in the kitchen. Different kitchen, more code. Been exploring something I saw that caught my eye, which is a thing called Catmull Rom Curves, named after the two mathematicians who sort of theorized it. Basically, it's a way of thinking about the shape of a curve and describing it using 4 points. The beginning of a line, the end of a line, the beginning of a curve, and the end of the curve. And the curve goes through these 4 points, but it only gets drawn between the two middle points. So depending upon where the end points are, it changes the shape that the curve makes between the beginning and the ends of the line. And if you've seen things like Bezier curves in drawing programs, where they have little handles, and as you twist the handles around the points that the curve goes through, it changes the way that the line works. That's basically it. There should be a diagram somewhere about here that shows what the maths is, and there's a bunch of links to it. But basically it's a way of drawing smooth curves through multiple points. And I was thinking about this and the work that I've done with things like drunkards walks, and imagined this idea in my head and thought, well, I'll just code it up. So this is a really quick thing about making generative drawings with these beautiful curve shapes. And exploring some of those ideas. So let's dive into the code. This is openFrameworks again. I've set up a simple project. I'm going to make the text a little bit bigger here. So I've just got a basic openFrameworks project. So you have a setup routine, update and draw routine, and I'm getting some key presses. And I've set up a couple of basic variables that I'm going to use. Because I want to draw these curves over time, I need to keep track of when is now and how long things take. So I've set up some floats, which is going to keep the time of how long I want things to take and the time when we started doing that thing. So I can say, have we got to the end of this now? The position that we are in a curve, because I'm going to say, hey, make a curve and draw from here to there. But I need to know where we are right now in that drawing curve. And then to make the curve itself, I need 4 XY points. The start point of the curve, the end point of the curve, the beginning point of the drawing, and the end point of the drawing. So I've used a new syntax for making these curve points, which is X and Y coordinate, using vector 2, using GLM. So this is a new maths library in openFrameworks, and basically you declare them like normal, but it's a slightly more modern way of doing it. So I had these 4 points, X and Y, start point, end point, start curve, end curve. And then what I wanted to do was just take the screen and give me 4 points randomly anywhere on there. So we're using openFrandom, but within openFrameworks there's an additional kind of thing where we can say, okay, I can get the width of the screen and randomize it to the width of the screen. But there's actually a command openFrandomWidth and openFrandomHeight, which just is go and find that out for me. So it reduces one step, which is kind of cool. So I'm going to say the start point is X and Y of the random width and the random height of the screen. And because it's a vector 2, like we're combining these two values, two floating point values together to make one object, we just say, hey, pass this over as a vector 2 object. And then I do exactly the same for the end point, the start curve, and the end of the curve. So I get these 4 random points. And because I want to draw where we are across a curve, I'm going to get whatever the time is now and put it into the value time now. So when we started a thing, that's the time now. And then I can count up to see, have we finished it? And I'm going to say the thing that indicates that we finished it is that 5,000 milliseconds have passed. So that's the value of how long I want things to Then I set the background to be black, and I'm going to set the frame rate to be quite fast. And then every time the screen updates, I'm going to ask this question: if the time now is greater than the system time in milliseconds right now is greater than time now when we started doing this, plus our 5,000 milliseconds, i.e. from when we started, 5 seconds has elapsed, then reset the time, so grab the system time and update when we started time now, and just make new endpoints. And what I'm doing with endpoints is I'm imagining I want to go through a curve, and then another curve, and another curve, and another curve, and I want to start the new curve at the point where I ended. So my new start point will be the end point of my previous curve. So I just need to make a new end point each time. So I say the start point of my new curve is equivalent to the end point of my last curve. And then in a draw routine, I'm just saying, make me a drawing color and make me an object, a vector2 object, an XY point called drawing point. I'm going to set the color to be 255, 255, 255. So I'm going to draw in white. And here we go, set it to that drawing color that I've just made. And what I need to do is I'm going to use this useful openFrameworks command curve point. And it's a maths library thing that just says, hey, imagine this curve that's using a Catmull Rom algorithm to make the curve with a start point and a start of the curve and an end of the curve and an end point. So it gives us this curve, and tell me the XY position of a dot on that curve. So that's why it says, give me a curve point. And we need to tell it where on that curve we want to find out what the point is. So I can say, okay, here's the curve at 50% along the point, this curve up here somewhere. What's that point in X and Y? And every time I ask the draw loop, I'm going to say, start at 0 on the curve and go along to the end of the curve. And I'm just going to draw a dot there every time. But I need to know how far along that curve we are. So I'm going to say, let's do it over time and take, if we come back up to the top, this 5,000 milliseconds or 5 seconds. It takes 5 seconds to go from one point to the other. Now, when we ask this command or this function curve point to give us a point along this curve, it's expecting a value between 0 and 1. Lots of stuff does this, so it's normalized. So we need to say, tell us a value at 0, 0.1, 2, 3, 4, 5, blah, 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 to 1.0. So I'm just going to get the time now and find out how far that is between time now when we started and where we want to end, which is 5 seconds later. In this way, I can give it, here's the range of numbers that you're expecting. Here's the one we've got right now. What is that normalized to between 0 and 1? So it'll give us out something between 0 and 1 as we go along the curve. And I'm putting it into t. So I want to find out the point where we are right now on our curve, denoted by these 4 points, start and end and so on, at t along the curve. And that goes into draw point, which is just an X and a Y. And I'm going to say OF, draw circle at that draw point and do it as a radius of 3. So when I run the code, it looks a bit like this. And you can see there's our little white dot moving around the screen. Kind of nice. It's looking a bit, it's a bit like it's floating about. So what I'd really like to do is draw these curves, and I could do it in a bunch of different ways, using a polyline and filling the polyline full of points and then drawing the points. And actually the simplest thing that I can do is switch off the background refresh. So when it draws a dot, it doesn't clear the screen before it draws the next dot, so we get trails of stuff. So in my setup, I'm going to go to OF set background auto and tell it to be false. So it doesn't automatically clear the background every time we run the draw loop. So now, when we run the draw loop, it won't clear before drawing the next dot, so it'll still have a trace of the previous dot on the screen. And then we get a much better idea of what's going on. So you see, every time 5 milliseconds passes, our 5,000, it finds 4 new points on the screen, plots a curve between them, and draws a dot along that curve, anywhere on the screen. So you can see some of the curves are quite tight, some are quite long. And you can see where it's got a long distance to go, the dots are a little bit far apart. So you can see them separated, and it starts drawing away. And it's kind of beautiful. Yeah, I'm liking that quite a lot. And that's sort of what I had in my mind, and I'm just going to twiddle with it a bit. The first thing I'd do is I'd like to be able to run it full screen. So I've kept a couple of routines in here, including the key pressed routine, which is standard in openFrameworks, and I'm going to use a switch statement to say, grab the value of whatever key's been pressed, and if it's F, use toggle full screen, which means it'll just go full screen or not, depending upon which one it is. Now I've got this switch statement, I could add in more controls if I wanted to change color or speed things up or whatever else. And I'm just going to go and see, here in the timer, I could set it to be much slower to draw the curves, which means each curve is going to be drawn by more and more dots. So they're going to be more consistent and less dotty. So this is 9,000 milliseconds, or 9 seconds. So it's going to draw much slower, but smoother. And also, if I press the F key, it'll toggle it to be full screen. And because it's saying OF random screen width or screen height, I don't need to go and reset the values for the new size of the screen. So there it is, drawing away. And I toggle it back to from full screen. It's drawing these beautiful curves, and maybe I'll let that run a bit and speed it up. You can see what's going on. kind of what I wanted. I'm going to set the frame rate back a little bit, but what I'd like to do is have it maybe be able to change the thickness of the line. Because if I come to the blob that I'm drawing and maybe make it 10, this is an OF draw circle, they're going to be much closer, they're thicker, and they'll overlap more. So I'll get a smoother looking line. So here's my 10, and you can see, because the blobs are bigger, they overlap more, and I get a much more consistent line, but it's got a different kind of feel to it. And it would be kind of nice to do some different things with it. Part of me wants to resist this because the obvious thing is to make the line thickness change as I'm moving it around like it's a physical thing, and then it starts getting a little bit painterly, which is not quite my thing. But I'm interested. I've got something in my mind. I want to see where it goes. So what I can do is I can change the size of the drawing point, the radius of this dot that we're drawing, and rather than doing it by stroke and picking up the velocity, I just want to change it over time. And we've seen this before when I was reworking a piece of Zach Liebman's code, looking at algorithmic drawing. And I'm going to draw my point at X and Y. And then here, I'm going to use the sine function. And I've made a float variable where I'm just grabbing the elapsed time. And I'm feeding that into the sine function. So over time, the sine function will make me a smooth curve. When I ask this to draw, you'll see that dot size changing, not according to the curve that we're making, but separately over time, as we're feeding time as a changing value into this sine function. And I'm really liking that. I'm kind of digging that. That's really nice that we have these curves, but it's not quite painterly. It's doing something slightly different. I'm really liking that. So you see we're choosing these curves each time, and then we're using time as an input to a sine function to change the size of the dot. So I'm liking what's going on, but it loses something a bit as the lines get more dense. So what I'd like to do is alter this a bit. And in my drawing color at the moment, we're just having 255, 255, 255, which is the red, green, blue. So it's 100% white. But I want to add an alpha channel at the end. So I'm going to add like an alpha of 20 and see what happens. So it means that all of the white dots are going to be 20% or 20 out of 255, which is like 10%, 10% opaque. So quite transparent. Where they're overlapping, they'll build up. But where the lines cross, it should give me some kind of density to it. So you can see where the dots are overlapping. We're getting this sort of reticulation, a bit of an earthworm segmentation thing going on, but it gives us a lot more depth to it, subtlety to it. I'm liking what's going on. And it has this depth and something skeletal about it. It's a lot less painterly, which I really like. And it has this non-organic feel to it, like a machine organic, which I like. But there's a couple of things I'd like to try with this, which is what happens if we start drawing in color. So I make this OF color called draw color, which I'm using to say set our drawing color using set color. And at the moment, we're just declaring it as an RGB value. But as we've seen before, we can declare stuff with hue, saturation, and brightness, which means we can control things in a different way. We can say, set this to be red, and then manipulate the hue, the saturation and the brightness of that. So we can choose a color palette and alter its brightness or its saturation, or keep brightness and saturation together and make more uniform colors. And I'm going to use this sign trick again. And I'm going to set draw color via HSB. And the first value here, which is our hue, I'm going to say vary across 255. So it'll go red, orange, yellow, green, blue, indigo, violet, and back. Let's have a look what we get. So you can see it's progressing blue through to red, and it'll go on to orange and yellow and green. And by changing the values that I'm putting into the sign, at the moment I'm using time and multiplying or dividing time to change the speed, I can make these palette changes very, very slow. So I can say I want this to draw for a whole day and have it take the whole day to change the color of the lines. Or I want it to run much, much faster. Kind of liking that. That's working okay. I wonder how it will look if I make it super fat. Let's do that. So the drawing point here, we're altering a radius of the dot using this sign function, using time as a variable input. Let's change it from 60 plus 55. So the smallest it'll be is 5, and it'll go up to 111, 115. So we should have a small dot going to a really fat dot. Okay, that's a really fat dot. Very different feel. Getting somewhere. But there's a thing I'd like to do. I don't want that to be so big. I like it smaller. So I'm going to go back to the 6 and 5 here. And with HSB, at the moment, we're going across the whole color spectrum, but not feeling this super bright, radiant rainbow color. So what I'm going to do is I'm going to reduce the hue, the saturation to 200, so it's a little more muted, and the brightness down to 170, so it's a little darker. And then instead of using 127 plus or minus to go from 0 all the way across the hue spectrum, I'm just going to go from 0 to 20, or 0 to 40, which is going to go across the beginning of the hue spectrum. Red, orange, yellow, orange, red, back again, just backwards and forwards in that color range. Again, feeding it time to give us our speed of change. And see what we get from that. So you can see less saturation in the color range and less brightness. And it'll oscillate between oranges and yellows to reds and then come back again. I'm loving what's going on here. This is much more what feels right for me and the things that I'm interested in. This muted, narrower color palette, gestures going on. But one thing is bugging me a little bit, that everything is filling the whole screen because every point that we choose is random for each curve. And although there's parts of the kind of gesture in the curves that I'm liking, in my mind I want something that's smaller and closer and more interlinked. So I'm going to use a technique which we've seen before when I've talked about drunkards walks or random walks, which is basically saying choose a point somewhere and go to another point within a certain distance of that point. And then from that point, go to another point within a certain distance and on and on and on. So you get this random walk. And at the moment, we're just going any point to any point to any point. So I want to start off like that. And then so when we make the next curve, the curve has got to be within a random certain amount. So we get this interlinked random walker and we draw curves to each point. So we'll get a denser, more closely aligned set of curves, I think. In our update, I'm saying when the system time has reached when we started plus 5 seconds, choose a bunch of new points. I've copied that routine to make a drunkards walk version that says, okay, if we've come to the end of our curve after 5 milliseconds, update the time as before the start point of our new curve is the end point of the old curve, and the start of the curve is the end of our old curve. The new endpoint, instead of being the random width and height of the window, I'm saying get our new start point and choose an endpoint within 200 pixels each side of it. So minus 200 or plus 200 in the X and the Y. So I knew X is going to be wherever our start point is, anywhere within 200 pixels. And the same with the end curve. Now, one thing I know straight away, going to give the game away, is that this potentially could go out of bounds. The random walker could start going off to the side of the screen and just disappear off. So I'm not doing any of that checking, but I'm kind of thinking that's okay. Because what's nice about this as a drawing or a painting or a piece of generative art is that there's an end, and somehow that makes this one feel constrained. Because I couldn't just leave it running forever and ever and ever. And then there's something about the scarcity of going, this will end, which I quite like. So we're going to run this Drunkard's Walk version, see what we get, given that it's quite happy to run out of bounds, and that's the end of the drawing. So you're getting much closer clustering of the curves. And even though I'm setting with HSB, I can add an alpha value as well. So I can do HSBA and have an alpha at the end so that there's a transparency overlaying. Okay, that's the end of that drawing. That's run out of bounds. Let's start another one. And I could have the space bar so that when it runs out of bounds, I hit the space bar and it starts a completely new one by adding a routine in. But at the moment, I'm just going to do it brute and recompile and make it draw. Let it run full screen and see what we get. I'm super happy with that. It keeps running out of bounds, which I'm enjoying, actually. I want to play with the colors some more and the gesture and the speed. There's so many variables that I can sit and explore. I'm going to stop the video there and say thank you very much for watching. Coding in the Kitchen, it's a thing. If you like this, please hit the subscribe. Leave me some comments down below. Show me what you're doing. The code will be on GitHub, on the Art and Code channel. So I'll see you for the next video, coding from the kitchen or wherever I randomly happen to be, showing you some things that we're making. See you next time.